In this video, we'll use the LV distribution network to show the voltage profile plot and the feeder load scaling function. Feeder load scaling enables the user to scale the loads connected to a feeder so that they match the overall values specified for the feeder. The feeder load scaling study case should be active. In this study case, there's just one feeder in service, FD126. Let's see how feeder load scaling works. Firstly, there's an option in the load flow command which needs to be selected. Secondly, the feeder itself has scaling options. Here we can see that the current setting is for the active power of the loads to be scaled to a total of 230 kilowatts. Thirdly, the loads contained within the feeder have to have scaling enabled. Let's look at the loads in this feeder. These charging point loads will not be adjusted by load scaling, but they're set to 0 anyway. The remaining loads can be adjusted by load scaling. Let's start by first running a load flow without feeder load scaling. We can create a voltage profile plot for the feeder. The x-axis is the distance in meters along the feeder. The y-axis shows the per unit voltage. We can also add a constant y value to the plot. The target is to keep voltages at or above 0.95 per unit, and we can see that this target is met at the moment. Let's look again at the loads in the feeder. The total active power is about 157 kilowatts. But we can see that if we run the load flow calculation with feeder load scaling enabled, the loads will be scaled to a total of 230 kilowatts, modeling an increase of roughly 50%. We'll select the load flow option and run the calculation again. As expected, the increase in the loads results in greater voltage drops along the feeder. Feeder load scaling provides an easy option for assessing different loading scenarios without having to modify the individual load objects.